Okay, good afternoon. First one, when you're coming down, I put some stickers there, so feel free to take them. I've got plenty of stuff to share with everybody, so please ask questions and then you get a t-shirt or maybe a book. I don't know. Okay, so I can hear myself, it's kind of strange. Anyway, expert troubleshooting. So I'm going to talk about some things on troubleshooting with MySQL. This is like the table of contents. So I'll talk a little bit about problems, what types of problems and what the problem is with problems. I'll talk a little bit about instrumentation, different ways of instrumenting for MySQL, but also a little bit more general about different aspects like response time, capacity, things like that. Then I'll go into 3 different types of troubleshooting that we often have to do in Percona as part of our consulting business. Is individual slow query, troubleshooting, seeing how we can optimize individual queries. Global performance problems, sometimes you have just a slow server because of some reason. And a very interesting one is the intermittent performance problems. So performance problems that happen at very random times for a very brief amount of time. Sometimes that's really a problem for some applications, costs a lot of money, so it's difficult to troubleshoot, but I'll show you some tools on how you can actually get more insight in that and try to find a solution for it. I'll use this thing here. Okay, so the problem. So the thing I see a lot is when some of our customers come to us, they say, hey, I've got a problem. What's the problem here? So usually we say like, we hear things like, hey, the website is down or the database doesn't work anymore. And then it's like, sometimes it's like, really? What's wrong? I mean, what's really going on here? And usually the information that we get from people is kind of, scarce or maybe not really what the real problem is. So it's the most important thing here is it's hard to find out what really the problem is. And in this case, I can't log in. That's one example. And I'll show you some more about this a little later on. Another one is like Tomcat doesn't respond anymore. How do you know? I've had several discussions with some of my friends on IRC, like they have some problems and then we try to troubleshoot it just for fun. We try to help them. And then it's like, okay, how do you know that Tomcat doesn't work anymore? Because, I don't know, did you check the error logs? I didn't. Did you have so many monitoring? Nope. So there's a lot of times we don't have the right instrumentation, the right tools, the right data to actually find out what is really going on. Is there something going on? Is there any change of behavior with compared to things that were happening, just before the problem happened, things like that. Also, another problem is guessing. Sometimes they say, okay, this is a Tomcat example here. I like to use Tomcat as an example. It's probably something to do with the connection pool. Okay, why? Kind of a problem. So the thing is finding out the real problem is hard. What's really going on. The problem with those definitions about these things is that we kind of limit ourselves. When we talk about some problem with a customer, we try to not try to listen to what they actually already think is going on. When they say, hey, it's probably Tomcat connection pooling, we try to say, hey, that's not something that we want to hear. We want to know, what do you see? What is the application? How is it behaving? Because otherwise we kind of limit and our area of focus, we kind of narrow down the vision that we have and we kind of only focus on connection pooling then, but there's like no real indication that there's something going wrong with connection pooling. So the lesson number 1 is don't trust anybody, including yourself. And guessing is also kind of lying to yourself. So that's an important lesson that I've learned over the last couple of years. So we're talking all about measuring and instrumentation here. So you've got to measure like a boss. So instrumentation, very important. There were some talks yesterday about instrumentation as well. Sorry about that, I need to drink sometimes. So it's the branch of mechanical engineering that deals with measurement and control. So one famous quote here is, you can't control what you can't measure. So that's a very important thing. We need to measure, we need to have the metrics, we need to know all kinds of things. The example here is, try to use this. Can you see that? the laser? Not really. Okay. So if we look at a car, we all know how fast is our car going, how far did I go since I last got some new gas, how much fuel am I consuming. These are all kinds of metrics that we have, and we should have that in our application as well, but also in our database. And very important to be able to understand the real problem. So why do we need to instrument? In a lot of cases, there's a guess, and that guess, I said, you're kind of lying to yourself, but in many ways, you're right. You're experienced in that area, so you might think that this is the problem, and maybe you're right most of the time. The example of like logging is slow. So we've got logging on a website takes 15 seconds. So we've got a bunch of web servers and we've got a MySQL database. Okay, so where do you think the problem would be? The first guess always is it's MySQL. There's only one MySQL box, so can't be the web servers. You know, there's many of them. It scales and everything. So okay, you're thinking the database. Probably right. There's a lot of challenges with databases compared to applications. So yeah, we're good, but we kind of need to know what's going on here. So proving. Important thing that we don't often see in applications is that you need to monitor and instrument what your application is doing, how much time it is spending at various types of tasks that it's doing. And one way to represent this is for showing a flow like this. So where you got submitted a login form, and that's the amount of time that it takes. So it's a sequence diagram. So this only takes a small part. So checking if the user exists goes really fast. But somehow we kind of update the last login date of a user, and that seems to take a lot of time. So by having some kind of instrumentation like this, I know it's not easy to make something like this in your application server, but at least knowing at which stages of your application or your complete architecture it is spending time and how much time, you kind of can figure out, okay, we spent most time here, so if we want to make things faster or if we want to fix our solution, it's probably something to do with updating the last login date. Okay, so that takes a lot of time. So why is this taking so long? So this is the query that's being used. So we're updating users, and we set the last login date to now, where ID, so user ID. So a very simple thing. Yeah, probably a very easy one. ID is probably primary key, so there should not be a table scan here. So it should be pretty fast. Schema is also very, very simple, very straightforward. So we've got ID, primary key, a lot of columns, and we've got last login date, which is one of the columns. Now, if we do show full process list, what we see is, and yeah, it's a little hard to actually read, but we can see that the second query is the one that is updating the users and setting a last login date for one particular user, and all the other users are actually locked. They're waiting until the other one completes. So in this case, it's using MyISAM, and MyISAM has table level locking, and you can only write one query at the same time, so only one write can happen at the same time. So that kind of, yeah, is a kind of a problem. But you can see that this takes 2 seconds. So this is the time that the query is running. So 2 seconds is quite a lot to just update that small column. Why is that? So here we understand that. We can see by running show process list that this is causing a problem. If we would like just look at general metrics like uptime, load, CPU usage, we could see like, okay, load is 0.88. It doesn't mean that even though there's a lot of things going on here and a lot of locking and a lot of waiting here, doesn't mean that CPU must be like 100% used. Load is very low here. So by looking at global metrics, you don't always get the information you need, or you don't always see that, yeah, the problem is not in the database because there's no CPU load. It's not always true. In many cases, it is not. Another thing we could do is we could do show global status like slow queries. See how many slow queries we had over a certain amount of time. And we can see that there were only 3 slow queries since the start of the MySQL database. However, slow queries by itself were configured long query time set to 1 second. So you would assume that if it takes longer than 1 second, it should be a slow query. But that's not true because lock time, as we can see here, they're all locked. That time doesn't count for the long query time. So another problem, another thing that you have to know about how MySQL looks at that. Okay, so some problems don't come with load. So utilization rate, CPU, disk I/O, that doesn't always show you what the real problem is. So just don't guess. Third time I said it, I'll keep on saying it. Don't guess, try to prove it. Very important. It actually makes, if I can prove something, it makes me feel good, you know? And if I can fix things and I didn't prove it, I feel bad because I don't know why I fixed it or how I fixed it or if that even was the problem. So, yeah. Now, some concepts about instrumentation and response time throughput. So load is how much work is currently coming in. Utilization, how much of our resources we currently use are being used at this moment. Scalability is what is the relationship between utilization and R? R means response time. So throughput is how many tasks can we do in a certain amount of time. Concurrency is how many tasks can we do at the same time. And capacity is how big can X, so the throughput, go without making other things unacceptable like response time. So there's like a lot of connection between those things. And some of the most important things is response time is how much time does it take to do a certain amount of tasks, how much time it takes to do one certain task, and throughput X is how many tasks can I do at a certain amount of time. So often we look at throughput, we can see, hey, we're doing 1,000, 2,000 transactions per second. That looks good, but your response time might be very, very bad. So throughput is not performance, it's the relationship between all these things: throughput, utilization, response time, and capacity. So R, response time, I have to say it's the combination of both the service time, so the time it takes to do a certain task, and the queuing that has been involved in that. So we need to take that into account. Now, about MySQL, where do I need to look in MySQL? So the common ones that we do is we know the error log. Is something going on? Is it crashing? Do I have a crash table? Things like that. Show global status shows us a lot of status counters. Very interesting, but yeah, running show global status by itself doesn't really give you much of an answer for some types of problems. I'll show you some more examples on that later. Show engine InnoDB status shows you InnoDB specific information. So InnoDB is a transactional storage engine for MySQL. You've got the operating system metrics, so CPU, memory, disk, network, whatever. So measuring performance, we often recommend look at performance, do it in your application, because your application is doing the database requests. So you're making the application usually. So you have the control in adding that metrics to your application. So you can add response time in your application or in your web server, whatever you want. MySQL by itself gives you a lot of troubleshooting, and I'll show you some more on how to identify those things. But if you have it in your application, you can have it real time. So one example we have here is from a instrumentation for PHP. It's a small PHP class that actually gives you the following information for every request or every certain percentage of requests. And important is that we can actually use this to make some powerful metrics. We can see how much time it took in MySQL, and you can see that this was only 4 milliseconds. Sphinx time, so Sphinx is a full text search engine, often used in collaboration with MySQL, is about 83 milliseconds. The total time it takes, so user time, is 129 milliseconds. So if we look at that, we can say, okay, Sphinx is taking up most time. So if you want to optimize it and make this page faster, we just need to optimize Sphinx, because optimizing MySQL will only gain you 4 milliseconds out of 129. So you have to focus on what is most beneficial to you. Other important things is you can see how many queries we're doing. This is an example. Many applications have much more information. But a very important is a page type and maybe the page request itself, which is on top, page. So we can actually, with this information, we can make look at response time. We can look at how much time it takes to do a certain type of page, or look at the different types of requests that we have and what the response time is for that. We have the time when it was logged, so we can see, is it happening over the whole amount of time throughout the day or throughout the week? Is it busier? Is response time higher at peak times, like 7, 8 p.m.? Is it more busy on Wednesday afternoon? Is it more idle? That allows you to make some queries, look at 95 percentiles, 90 percentiles, and really see when the load is actually higher, how it affects your response time. So that was instrumentation for PHP. So that's just a small open source project here. Yeah, you've got New Relic. That's application performance monitoring. There's many other solutions. New Relic is the one I know best. They do similar kinds of things and much more. So very useful if you have that. Don't have that yet, I recommend looking at that. About MySQL itself, we do have something called Percona monitoring tools, and it's a set of scripts that plug into Nagios and Cacti. I know it's a little, yeah, Cacti has been there for a long time, but we have those graphs for a long time already. But it's quite often used because we have some nice graphs for Cacti for MySQL, and I'll show you some later on. Okay, now, individual slow query. So in this case, we try to look at a certain single query, see how we can make it faster. I'm not going to explain you how to make it fast, or I'll tell you how to optimize it, add indexes, things like that, but I'll just show you which things you can use in MySQL to get more information about it and learn more about it. So we've got explain, show session status. You've got show global status as well, but in this case we're looking at the session status. So when we run the query, we can see in that session how many things it did. I'll show you some examples, how many rows it read, how many sorts it did, things like that. Show profiles, it shows you some profiling information, where it actually was, in what kind of stage internally in MySQL was the query taking most time. So sometimes it really reveals some information, but not quite often used. And one feature we have in Percona Server, and is also in MariaDB, is slow query log extended statistics. So we have a lot of added statistics to the slow query log. If you look at Oracle MySQL, they have rows read, rows examined, rows returned, and the time it took. But we have so much more information about all those specific session status variables, how much more fine-grained detail on what it was actually doing. So it helps you better understand and helps you how to optimize those queries. More examples later on. So we've got some kind of a query. So it's a select straight join count from cast info join title. So this is from the IMDb database, which you can freely download from their FTP servers on imdb.com. So if we explain it, we can see how MySQL will actually execute this. So yeah, as I said, I won't go into many specific explain you what is wrong with it or how to optimize it. But we can see that it's a join between two tables, and it starts with the first table called cast info. And it is actually using an index named person ID to execute that. It is doing a table scan, it is using a temporary table, and it is doing a file sort. So it could not use an index to do any sorting. So for every matching row it has here, it will actually join with the title table, and it will use the primary key to actually find it. So here you can see that this kind of, shows you how it is being executed, how the optimizer will execute that query. So we've got explain. In 5.5 and before, you could only explain select. Since 5.6, which has become generally available in the last couple of weeks, you can explain updates and inserts and deletes as well. So this gives you information. So if you change some, like remove the straight join, maybe it will execute differently. If you add an index, see how it behaves on that. Maybe you can set some optimizer settings on a session basis. It might execute differently as well. But what you can see, there's an estimate on how many rows it needs to read. So it guesses, so based on some metrics about the index, the table, and everything, it does some cost-based optimizing, and it thinks it will read about 8 rows on the first table, and for every matching row, it will read read maximum of 1 row. So that should be a very fast query. It's not always the case. There are bugs. It is a guess. It's an estimate, especially with InnoDB. Those statistics are estimates based on some random pages that it takes. So it might not always be perfect. But it shows you the intention MySQL has. And that's a little bit of a problem. It's not what MySQL did. And many other databases have that information easily available, and MySQL Explain does not show you that. However, show session status shows you that information. It's not that easy, especially with this kind of query. You were thinking it was working really fast, but it wasn't. So what we do is we flush the status. So on top, we remove the session status. We put everything we can on 0. We run the query, and then we do show session status like HA. So HA handler, show me everything that starts with handler. And the handler interface is the API between the MySQL core and its storage engine. So it kind of, MySQL core tells like the storage engine, give me the next row of that table, give me the next row, write some row, read some index. So that the statistics between in that interface actually show you a lot of information. So what we can see here, and then I'll show you some important ones. We've got handler read first, handler read key, and handler read next. So first is like read the first index entry of that index, so leads the first row. Handler read next is read the next one. So you can see that this happened for 14 million times. Read the next row, read the next row. Can you hear me coming? It's not going to be very fast, that query. So 14 million times for that specific query. Handler read key means read a specific index entry. So the namings are not really clear, but yeah, it's well documented on the dev.mysql.com website. So it read about 13,890,000 times, read that specific index entry, read that specific index entry. We've got handler read R&D and handler read R&D next. R&D does not mean random, this is about reading an index, this is about reading a row. So we can see that this is, give me the next row, read the next row. So this is actually a table scan. So this is an index scan, give me the next index entry. This is a table scan, give me the next row. Give me the next row. This happens for only 2,407,000. And another interesting thing, and that's where it kind of lacks good insight on what it really does, and you kind of need to understand it, is that was just a select. But what we see is that it does about 2.4 million writes. So this actually comes from reading from a temporary writing to a temporary table. So as you see here, it was mentioned it creates a temporary table to do some sorting similar. So what you can see is the temporary table is actually 2 million rows big. So that's quite large already. And we can see that this kind of matches with handler read R&D next. So when a temporary table is being created, there's no index on that temporary table. And the results will have to be read to be further processed. So you can see that it read that whole temporary table again to return the results somehow. So very interesting one. So if you understand a little bit those things and see like temporary table, file sort. So what we can see is this was an index scan. So those metrics came from the first table, and the join we did here was actually handler read key. So it was read a certain primary key, read that entry. For every matching row here, read that entry. So we can see here that it did that for about 13 million times, and this is the size of a temporary table. So it takes a little bit of experience to get familiar with it, but very useful post-execution analysis of this. Very good. Now, profiling, not quite often used, but this is how you enable it. Set profiling equals 1 on your session. Run the query, do show profiles. The query that we ran comes up, and we can see the profiling by doing show profile for query 1. And this is what is being outputted. So you can see the different states that it goes through in MySQL. And we can see that most time, this is not really, perfect numbers, but they show you a good indication, especially here. Copying to temp table was 113 seconds. copying to temp table on disk. So sometimes MySQL converts a temp table when it becomes too large in memory. It makes it a MyISM table on the temporary, directory on the file system. So you can see that this took 96 seconds. So there's some room for optimization on that. I would recommend to just fix the query by itself instead of putting the temporary table directory on a shared file, on a memory file system. But it does work in some cases. So here we see that this time is spent on that state. Not quite frequently used, at least not in my case. Now those extended slow log statistics give you similar information, like the show session status. And it's a little bit, I think it's very easy to read and very easy to understand and good for logging as it becomes logged in the slow log. So set global long query time 0. We log every query that is going to be run on the database from now on. And we set the verbosity to full. So this means give us all the metrics you can give us. And this is all the output from one certain query, from that query. This is all the metrics that we get out of it. So what do we see? There was a lot of InnoDB IO reads, so this read a lot of bytes. Was it a file sort? Yes. Was it a query cache hit? How many disk temporary tables were created? How big was the temporary table? Very nice, very nice. Yeah, everything that you can imagine is in there. So that's really good, especially if you can log it to a table, log it to a file, and then analyze it with some tools, which is something I'll show you next. Any questions so far? I still have a lot of t-shirts, and otherwise I'll just throw them away. Yes. Here you go. Yeah? Perfect. If you wait a little bit, I have a perfect example that shows you how to analyze that. It's a pretty common problem, indeed. I'll show you if I have time. But yeah, I'll definitely get there. Any other questions? I've got 7 or 8 of them. No? Oh yeah, sure. Oh, sorry. I don't know if InnoDB uses it, but they have CSV files on an FTP server which you can download, and there's an open source project on SourceForge that actually adapts it to be imported in MyISM, InnoDB, or Postgres tables or Oracle. So it's kind of a tool that is written around it to be used. So, yeah, indeed. I don't know, probably, yeah. Yes?
You mentioned that it uses MyISM table contemporaries without any indexes. Why is it doing that exactly?
Sorry, can you repeat?
Hi.
Yeah.
Why doesn't it put indexes on its temporary tables?
That previous query?
Yeah.
Why is it creating a temporary table? It's a good question. I need to check this.
Why doesn't it use an index on it?
Probably because there's some index missing. So it had to do some kind of sorting. There's a group by here, very easy. And it couldn't use an index to do the group by. And in order to do the group by, it creates a temporary table to do that. So we can adapt indexing maybe, add some composite indexes to actually make sure we don't need to create a temporary table in that case. And then it would be resolved. Although there's a lot of limitations around indexing and everything, so I can't really go into specifics on how to optimize this particular case. But I can show you afterwards on how to leverage that after the talk. Is that okay?
Well, actually I meant, you say it makes a temporary table without an index.
Yeah, so, okay, sorry, I misunderstood. So it doesn't, a temporary table by itself is called a memory engine. Yeah. So it doesn't make any indexes because you don't do create temporary table, which is also possible. It makes it automatically and it doesn't create an index. MySQL just says, okay, I need a temporary table. MySQL doesn't know which indexes to create, so it doesn't. It just makes a table to dump the data in and then retrieves and does a full table scan on that.
Right.
Okay? Perfect. Okay, global performance problems. Let me check the time really quickly. Okay, I'll go fast. Okay, example problem. 95th percentile of the response time has been increased from 40 milliseconds to 200 milliseconds. So what's going on? How do we get more insight in that case? How do we know what's going on here? So I recommend to use trending graphs, whatever you use. I'll go show some very old cacti graphs, but there's a lot of variants about it. So if you've got Percona Ganglia plugins, there's graphs for Zabbix, for everything, pretty much everything. A lot of other graphing engines actually use our graphs as a basis because they are really useful graphs. They show you some really useful information. So we want to look at more granular data, like really rows read on the database that really shows you more than just a query, how many queries per second. I can show you some graphs. Other tools that we can use is Systat, IOstat, MPstat, VMstat, pt-mext, pt-diskstats, IOprofile, PMP, and pt-query digest. So I'll go through all of them, but I'll skip some of them that are less important. So Systat is probably well known, IOstat, MPstat, and VMstat. So look at IO statistics, CPU statistics, and virtual memory, or more global statistics. This is part of the Percona Toolkit, and I'll show you some of them really quickly. But first, some graphs. Having trending, I won't go and say what the problem is, but trending allows you to see what patterns changed over a certain amount of time. And the power of the graphs that I think about the graphs we have here is we don't see one metric and how it evolves, but we look at some metrics that are like connected to each other. In this case, it's about connections. So we see here the amount of connections created, the amount of threads that were connected, so we can see that there was a slight spike here, so it might be a good thing to investigate that if necessary, or to understand why this happens. So it's all about understanding. About replication, we can see that replication is lagging from time to time up to 10,000 seconds, but it kind of catches up like during the night. But at some point there was like a big delay and replication never caught up through like more than a week. So there was kind of a problem there. So we can see that if there was an application problem, you had some stale data returned on one of your slaves, that's probably causing it. What is causing it? Yeah, that's something else you have to investigate. Same about temporary tables, how much are created. What we can see here, this is a pretty strict pattern, probably some cron job running on every hour, so you can see that this increases a little bit, the temp tables being created. So that's a good one. There was a slight spike in the one here, but yeah, if there's no real problem, don't go and find out. But if there's a problem, it helps you to understand what the MySQL did differently. Another useful one is InnoDB buffer pool was empty. We just restarted the database here, and you can see it takes a lot of time before memory is becoming full again. So you can see that this kind of affects checkpointing, so writing the changes to the table spaces itself in MySQL. So you can see that there was a lot of writes having to happen because the memory, because disk I/O was actually heavily utilized because of the reads, because of memory not being completely leveraged. Got some more graphs, some more fine-grained ones. Row operations, how many rows read, I/O operations, and buffer pool activity. So you can actually look at them together, see what actually happened. You can see some of the spikes match with each other, sometimes they don't. So you can see, try to understand what's going on here. Another useful one in Percona Server is the response time distribution. And the thing we see here is that it just counts the amount of queries that took a certain amount of time, and it adds up the total response time in here. So what we can see is this is a query that takes less than 1 microsecond, there were 0. A query that takes between 1 and 10 microseconds, 17 of them, and so forth. So from 100 milliseconds up to a second, 8,000 of them. And that was a total response time of 400 seconds. So it doesn't seem to look that interesting, but if you look at it over time, you can actually graph it, and you can see that that there were more queries. You can see it shift. I can actually show it better here. That queries actually, when there's more load, more throughput, that average, the global response time actually becomes slower, and those counters start to increase more. So if you can make it faster, if throughput is less, probably everything becomes a little bit more faster. So it's a good thing to look at it over time. pt-mext, so I mentioned show global status, shows you global status counters since MySQL started for most of them. So pt-mext actually shows you that over between a certain period of time. So we can see here, we look at MySQL admin ext, so that's show global status in command line, with an interval of 10 seconds, and we do it 3 times. So pt-mext just analyzes the data, just generates like a table here and shows you the value it was the first time and the difference in the second run. So we can see how many inserts were there in those 10 seconds, so 1,500 inserts. So if we have a certain problem or we want to look during peak, we want to use this, not global counters since the start 2 years ago of the database. So we look at certain small times and we can see that 10 seconds later we did the double amount of inserts. So very interesting. We can see that a lot of temp tables were created here, about 181 per second. So there's more here, and we've got the handler statistics again, but these are global now. So you can see the database wasn't too busy. That's about 3,492 times read a certain row. That's read a certain index. That's pretty good. If it's 8 million, I'm even not too impressed. So the box is probably not doing that much here. But you can see so much more about query cache, how many threads we're running. So we've got 5 running, 5 queries running at the same time, and 3 less at that specific moment in time, not in those 10 seconds. So some counters are like selected now, that many threads are running. So 2 threads were running when we did it again, and then 0. Very important for next chapter. So pt-mext allows us to investigate what's going on at a certain period of time. We often do this for our performance audits for customers. We ask them when is peak time. Okay, that's that day. We just collect the data when it's peak time because that represents the actual workload that we need to investigate. We don't want to know what happened over the course of one day. It doesn't give us any clue. Some of the tools available like MySQL Tuner and others look at global counters and give you advice on how to tune your database. That doesn't work. Disk subsystem, we've got IOStat, pretty common. Important things we can see here, SDB had an average wait of 420 milliseconds and a service time of 2.94 milliseconds. So this means disk I/O was pretty stressed here. We had about 338 writes and 0.99 reads per second. So that's not that much. There's something going on with the disk subsystem. Never look at utilization. Utilization shows you how many time, like if we do it like in 1 second, over the course of 1 second, in that last second, how much % of that second was there at least one request? And if you have one disk, it makes sense, but if you have a large disk subsystem or you have flash-based storage that can handle multiple requests at the same time, then yeah, that doesn't matter anymore. 100% might mean nothing. Now, the problem with IOStat is that it shows you, newer versions actually fixed it, is that this is combined reads and writes to response time. So we've got a tool, pt-diskstats, that looks at proc disk stats. And you can see read response time over write response time. So similar data that you can see here. There's a lot more, but I won't go into details here. Okay, optimizing queries. So when response time goes up, you look at pt-mext, you can see there's about 86 million here, maybe over 10 seconds. So we're doing full table scans because it's handler read RND next. So we kind of need to find out which query is causing this. You can do show process list until you find it, but yeah, you might not catch it. So we can look at the slow query log that I mentioned. So I showed you this before, all the metrics, but we've got a tool called PT Query Digest that shows you, that analyzes that log and can show you a good report about it. So what we see here is we can run it. There's a lot of features about filtering out, a lot of features. But what I want to show is that it analyzes the different types of queries, doesn't look at the actual data, just the type of query, and summarizes and gives you some percentiles, averages, and you can see what the average execution time is. If the average and the 95 percentile are quite similar here, so that's good, but maybe, there's a lot of variance between it. So this is the first query. Some distribution time, so 50% of the time it runs between 100 milliseconds and 1 second, and other times it takes between 10 and 100 microseconds. This could be disk-based reads, memory-based reads. Very interesting to know. There's a lot of other metrics about it. If you use the slow query log from Percona server, you've got InnoDB, I/O reads and writes and things like that. All the added extras. If you just use Oracle MySQL, you've got only those, those, and then it stops. Okay, intermittent performance problems. Now, we looked at global performance problems, but sometimes they happen, problems happen really, really like briefly. We've got, if you have like social games, then you really want to have a good response time. If it's becoming a little slower, users notice immediately, so you cannot afford to have that. So how do we investigate this? We got two tools called pt-stalk and pt-sift. pt-stalk, it stalks something until some kind of condition becomes true. So like by default it does, let me show you, skip you a little bit. So by default it actually looks at threads running. So here's a metric of threads running over a certain amount of time. Like usually it's 7, but then it actually goes up to 24. So there's some kind of locking going on. There's something going on. So pt-stalk can be configured to do anything. It can look at threads running. You can make your own scripts, your own triggers for it, like check various whatever application metrics, and as soon as that condition becomes true, it starts to collect data. But I mean a lot of data. You can do GDB backtraces of MySQL, O profiling, S-tracing, TCP dump data collection in order to see what kind of traffic was going on. Maybe not the first thing you want to look at, but all the other things are there, like operating system information, memory information, IO stat, interrupts, InnoDB status, all kinds of information. It just happens when you run it, it just starts collecting all that. So you can analyze it with a tool called pt-sift, or you can just read the files, and it shows you some summary, so you can see what kind of things were going on. It actually helps us in our consulting business when we have a customer says, hey, that problem happens. We don't go log in and monitor 24/7. We just say, okay, we'll configure it, and it sends an email to us as soon as something is collected, and then we go and analyze that data. So very easy. We usually find out what's going on pretty easily. So what's usually going on here? Full table scans, queries locking each other up, long transactions, as mentioned here, causing others to be blocked and causing a lot of performance degradation. Maybe there were some caching issues, some Memcache server crashed, causing more queries to come to the database layer, which kind of overloads the database. So there's a lot of stuff that comes, usually is being seen. Now, I've got some examples, but I'll take you the most interesting one, the transaction locking. Okay, that's the one that I wanted to show. Like, there's a lot of lock weights between each other. We could see that in show global status with pt-mext. There's some counters about that. But we don't know what it comes from, where it comes from. We want to know which query is actually causing this. So with the extended slow logging, we can actually log all that information, and we can see which transactions were locking each other. But it doesn't show you which one was causing the other ones to wait. It's a lot of data that you need to analyze. So what we would do is we configure pt-stalk. We write a script that looks at transaction lock weights in show engine InnoDB status. And as soon as they're a long-running transaction, we capture TCP dump data, which we can then use to actually transform into the queries and the results that were actually returned. Now, we convert it using pt-query digest, so it reads the raw TCP dump data, and then shows you some information. So show engine InnoDB status shows you there's an active transaction for 14 seconds active, but it's not doing any query, so it's doing nothing, sleep state in show process list. So it's not doing anything, but it's having locks. So it has 50 lock structures and has some undo log entries. So other transactions are actually waiting on that transaction to be committed, but it's not happening. And how can we know which transaction is actually causing that? Where in my code is there like a transaction being idle for a certain amount of time? So because we have that TCP dump data, we can filter out based on host name and port, TCP port. So we can use the thread ID and the IP with show process list, which will all be in the pt-stalk data, and find out, okay, that was that particular port. And as soon as we have that particular port, we can use the TCP dump data, or we can tune in with PCP dump and PT query digest and find out what was that transaction doing? Is it still doing something? And in that case, there was a loop in the transaction and in the application that was doing the same thing over and over again. So it was waiting a couple of seconds, maybe doing some processing in the application, and then it was actually doing some queries, but always the same queries. So that kind of helps us investigate those specific issues. Sorry, I have to go a little fast here. Usually I give this talk in an hour and a half, so I managed to remove 2 slides in total because I couldn't cope with it. That helped us. And I don't know, I've got 1 minute. Perfect. I can show you one other example. Sometimes query pileups happens, but we don't know. We actually investigated for hours and we couldn't see anything. Suddenly I/O went up, but MySQL didn't do anything. MySQL was like, I didn't do any I/O, I didn't want to do any I/O. So what we did, pt-stalk, threads running bigger than 10, started collecting data because things were locking up. Disk I/O becomes slow, queries are becoming slower, multiple queries are running at the same time. The whole thing comes to like an almost stop. But in the meminfo, we could actually see that meminfo, it contains multiple collections of the meminfo command, and we could see that write back was actually dropping to 0 and then increasing again. So it's a very specific problem, but it really helps us understand, okay, there's something going on. After a while, we noticed that, okay, every time that a trigger happened, so every time pt-stalk decided to collect data because that threads running became bigger than 10, we noticed that a new binary log was being created at exactly the same time. So not a coincidence, right? Nope, it wasn't. Binary log uses the file system cache to buffer writes. Okay, good. When a binary log is being rotated, it looks at expire log days and removes some old binary logs, right? So they have to be deleted. The customer was using extended tree file system, which is really slow in deleting files. So we had a binary log size of 1 gigabyte, so deleting that file took seconds. And because there was like an internal log, it's called the log mutex in MySQL 5.1 in this case it was, other transactions were being blocked by it. So one solution is go to XFS. It's super fast in deleting. It's usually much better than extended tree. It has less issues with database operations. And another solution was actually, let's shrink the size of a binary log to 50 megabytes and create more binary logs. So that actually resolved the spikes. It only had to remove 50 megabytes extended tree, which is much, much faster. It did remove more, but it was just smaller. So that's another way that we kind of investigated how something was wrong and how we optimized this. I have more examples, but I can't go anymore. I think I'm over time. So, any questions? I've got more t-shirts. Yes? Okay, wait for the microphone. Okay.
In order to do some reporting, I have to copy probably several 100,000 rows from an unindexed table. So I can join against it in real time. But I've noticed if I copy the data and then add the indexes, it's much faster than if I create the table, adding the indexes and then copy the data into it. Why would that be?
The reason why is that depends on which data you insert. Do you insert it in order or not? So you have a primary key, and if you insert it in order, it's easy to actually add the index entries. But if you have multiple indexes, those indexes need to be fragmented because it needs to update the B tree at several different places, so it becomes slower. So it is a good optimization to create just the primary key, insert the data, and then add the indexes, because then what it actually does, it does read the whole table, it sorts it, and then creates the index. So it kind of, it's a longer step, but it is a much more performing step. Actually, it's a good question because our MySQL, MySQL dump has a feature in Percona server that actually does that operation and creates table without the secondary indexes and then adds them afterwards just to make that step much faster.
Okay, thanks.
Good. Here you go. They're small sizes, sorry about that. Yes, question?
Thank you.
I was wondering if basically on MySQL on Amazon RDS you cannot choose what MySQL distribution you want, so you cannot install Percona server or MariaDB, and you cannot even SSH into the server. So
Yes.
I was wondering if you have any recommendations.
Sure. Like the pt-stalk example, what we recommend is fire up another Linux machine, and you can configure it so the I/O stat, the operating system statistics, it will create from that Linux server. But we configure MySQL to connect to the RDS instance. We have less metrics, but we can still do all those MySQL-related operations. There's also the slow log. You don't have that available in our Amazon RDS, but you do have a log table, slow log table, which is a CSV table, and we can easily convert that. We have some scripts on our blog, mysqlperformanceblog.com, that actually convert that in a slow log so you can use it with PT Query Digest.
Okay.
Yeah.
Thank you.
Okay. T-shirt. Yeah, one more?
Yeah.
Sure.
I already have one.
Okay. Say.
Why is it so much slower if you do an in on a table rather than having a couple of the same amount of items?
It depends. It does not always mean that. An in on it, yeah, where something in and then a couple of values is sometimes fast, sometimes it's not. Depends on the optimizer. It might choose to just decide, okay, I need to read a lot of rows anyway, so I'll just read a full table scan because I think it's going to be faster. But in reality, it is not. It's the optimizer that made a bad decision in that case. Optimizer is not perfect.
Right, okay.
Okay? Yeah, I'll be running around somewhere downstairs, so if you want to talk to me, I even have a book to give away, so I can see one more question coming up. Is that allowed? Sure. No question? No, we're done? I can't give the book away then.
What's the title of the book?
It's High Performance MySQL 3rd edition. Okay, a lot of questions. Come to me outside because I'm getting thrown out. Thank you.